Hi everyone, this is Mrs. G.A. and today we're going to learn how to find the surface area and volume of a pyramid. So first let's talk about the properties of a pyramid. So a pyramid is a figure whose base is a polygon, and then all of the faces except the base intersect at a common point, which is known as a vertex. So if you look down below, here you can see our base is a rectangle, here our base is a pentagon, and then the sides, or the lateral faces, all intersect at this point up here, which would be the vertex. And then the last property is that the faces that intersect, which are the lateral faces, are always going to be triangles. So for a regular pyramid, it has all those same requirements, except the base is going to be a regular polygon, meaning they have the same side lengths and the same angles within the base. And the slant height is the height of each lateral face. So if I were to look down at the images below, our slant height would be this height here. Notice from the top of this triangle to the base of the triangle, and notice it is perpendicular. And then our slant height here would maybe look something like this, and I'm working within this triangle. So the important thing is that we recognize the slant height is not this height here along the side. The slant height is the actual perpendicular height of each of your triangles. So the two formulas that we're going to be working with today are the surface area and the volume formulas. So you can find the surface area of a pyramid by finding the lateral area, and then you add that to the area of the base. So the lateral area can be found using this formula below. It's going to be 1/2 times the perimeter of the base times that slant height. So that's how you find the area of all of the sides of your pyramid, and then of course then you have to add in the base. The base of course will depend on what type of polygon it is, on how you find the area. And then for the volume of a pyramid, we do have a formula for that. It's 1/3 times the area of the base times the height. So the height is not going to be the slant height. The height would be the distance from the very center of your base up to the vertex, and it should be perpendicular to your base. So notice the slant height and the overall height are two very different things. Okay, let's try this first example together. Here we're going to be finding the surface area of this square pyramid. So for the surface area, a few things we will need. We will need to know the perimeter of the base. So we can find the perimeter of the base because we know that this is a square, so all of the sides should be 8. But the thing that we are missing is the slant height. So you'll see that we actually have the overall height of our pyramid, which is 6 meters, but this is that slant height that we will need to know to find our lateral area. So that's the first thing we're going to need to find. Luckily, we do have a right triangle given right here. And again, we know that this is 6. We can see that this is 4. So I'll call this S for slant height. And we can solve for that using the Pythagorean theorem. So we can say 6 squared plus 4 squared equals S squared. So S is going to be the square root of 6 squared plus 4 squared. So this will give us approximately 7.2 if we round to the nearest 10. So that's going to be our slant height. So from here, we should have everything we need to find the surface area. So following our formula above, first we're going to do that lateral area. So it's going to be 1/2 times the perimeter of our base. So 8 times 4 because it is a square. So 32 times our slant height, which we just found to be 7.2. And then we're going to add that to the area of our base. So we know that we can find the area of a square by simply doing the base times the height, or the length times the width, either way, and 8 times 8 is 64. So this should give us a total surface area of 179.2 meters squared. So again, here the tricky thing was noticing that we do need to find that slant height. Again, the slant height is the perpendicular height on the triangle. The overall height was here in 6, and that's from the base to the vertex in a perpendicular line. Okay, let's try another surface area problem together. So here we have what's called a hexagonal pyramid, and we call it this because the base is a hexagon, has 6 sides. So you can see we are given 2 things. We're given the overall height, and we are given the slant height. So one thing we are going to need to still find is we need to find the area of our base. So that's going to be tricky. We also are going to need to find the perimeter of our base. So one place we can start is we can draw a line that connects the center to this bottom of our slant height. And then here we do have a right triangle, so we can solve for this distance right here using the Pythagorean theorem. So we can say x squared plus 12 squared equals 15 squared. So I'm going to subtract 12 squared and take the square root of both sides. So here we get an x value of 9. So we can use this to help us find the area of our base, and we can also use it to help us find the perimeter of our base. So I'm actually going to redraw the base over here using what we know. So again, it's a hexagon. It should be a regular hexagon. And right now, what we do know is the apothem. So that's good news for us because the apothem is a part of the formula to help us find this. So remember, we can find this by doing 1/2 times the apothem times the perimeter. But we still need to figure out what the side length of this is. So we can turn this, well, first we know that the total sum of the angles in a hexagon is 720. We've done that multiple times in the previous few videos, so you can go back and watch that if you need, which means that each individual angle is 120 degrees. So if I do this, I draw a line like this, it's going to cut this angle in half, making this a 60-degree angle. And it is a right angle, so we can use that to find, I'll call this y. So this is going to be half of our side length. And we can find that, I'm going to slide over here, using a tangent ratio. Because if we have this angle, we have the opposite and the adjacent side. So that's going to be a tangent ratio. So we can say tangent of 60 degrees equals opposite over adjacent. So I'm going to multiply both sides by y. Y times the tangent of 60 equals 9. And then we're going to divide both sides by the tangent of 60 degrees. This we can plug into our calculator for a decimal approximation of about 5.2. So again, that's going to be the length of half of our side. So if we double that, then we know that each side length is going to be 10.4. So that tells us that if we have a side length of 10.4 and we have a hexagon, our total perimeter is going to be 10.4 times 6, which is 62.4. So now we have our perimeter, which is 62.4. We have our apothem, which was 9, and now we can find the area of our base. So the area of the base, which is that hexagon, is going to be 1/2 times 9 times 62.4, which is 280.8. So now that we know the area of our base, we also know that each side length is 10.4. We know also the perimeter of our base. We can find the surface area. So I'm going to do this above. So we're going to use that formula that we know. Surface area is 1/2 times the perimeter of the base, 62.4, times our slant height, which was given to us, which is 15. And then we add the area of the base, which we also found over here, which was 280.8. So this should give us a total surface area of 748.8 centimeters squared. So I know this problem was a little bit more involved because we did have to find a lot of the information for this hexagon. But once we have the information here, we're just simply plugging that information into our surface area formula. Okay, so now here we're going to be finding the volume of each pyramid. So remember, for volume, our formula is going to be 1/3 times area of the base times height. So let's look at this first example. Here we are given the height. Remember, the total height should always be from the center of your base up to the vertex. And then we have a square pyramid, so we know that all four sides should be 3 inches. So that means that we have everything we need to find the volume of this square pyramid. So we do 1/3. The area of our base is simply going to be length times width, so 3 times 3, which is 9. And then the height is 7. So this gives us a volume of 21 inches cubed. Remember, volume always has units cubed. Okay, and now let's look at the second part. Here, this is actually the same image that we had here. So luckily, we already know the area of the base for this one, and we are given the height. So we actually have everything we need to find this volume. 1/3 times the area of the base, which was 280.8, times the height, which is 12. And this gives us a volume of 1,123.2, and then it'll be centimeters cubed. So here we already did the hard part of that problem in the previous example, which was finding the area of that hexagonal base. Okay, let's look down here at this last example. So it says the Great Pyramid in Giza is approximately a square pyramid with the dimensions shown below. The pyramid is composed of stone blocks that are rectangular prisms. An average block has dimensions of 1.3 by 1.3 by 0.7 meters. Approximately how many stone blocks were used to build the pyramid? Round to the nearest hundreds. So for this, strategy-wise, we can find the volume of the pyramid, and then we can find the volume of an individual stone block, and we can see how many blocks would fit into that pyramid. So let's start by finding the volume of our pyramid. So first we can find the area of the base pretty easily because it is a square. So it should be the width times the length, 230 times 230, which will be 52,900. So we are also given the height of our pyramid, so we can find the volume by doing 1/3 times the area of the base times the height. So the volume of our pyramid, and I'm going to round again to the nearest hundredths, would be this number, 0.67. So we have 2,574,466.67. And of course, this will be meters cubed. And this is the volume of the pyramid. I'll say PYR. So now we want to know how many stone blocks were used to build the pyramid. So it'd be nice to know the volume of a block. So the block is a rectangular prism. So it would look, something kind of like this. And if we have a block a rectangular prism, it would be 1.3 times 1.3 times 0.7. So of course not drawn to scale, but it's really easy to find this volume. It's just 1.3 times 1.3, area of the base, times 0.7, or length times width times height. So 1.3 times 1.3 times 0.7. And that gives us approximately 1.18 meters cubed for each block. So now all we have to do is take our total and then divide it by the volume of a single block, and that should give us an approximation for how many blocks we use. So go ahead and we're going to do this number divided by this number. So when you divide those numbers, you should get so I'm going to round this number. So we should get 2,181,751.42 blocks. So this is rounded to the nearest hundredth. Now, in my opinion, it doesn't really make sense to have, a portion of a block. So I would round it up to the next whole number. But they did ask us to round it to the nearest hundredth. So this would be our final answer. Okay, so that is all for today's video. Thank you so much for watching.